Welcome to our journey into the quantum realm. Today we'll explore the basics of quantum physics, a field that has revolutionized our understanding of the universe. Quantum physics deals with the behavior of matter and energy at the smallest scales, think atoms and subatomic particles. Unlike classical physics, which describes the world we see every day, quantum physics reveals a world that's often counterintuitive and full of surprises. In this video, we'll break down complex ideas into simple concepts, making it easy for anyone to grasp the fundamentals of this fascinating science. Let's begin by understanding what makes the quantum world so unique. Quantum realm refers to the scale of atoms and particles even smaller than atoms, such as electrons and photons. At this level, the rules of physics change dramatically. Particles can behave like waves, and waves can act like particles. This duality is one of the most intriguing aspects of quantum physics. In the quantum realm, things don't always have definite positions or speeds until we measure them. Instead, they exist in a state of probability, only becoming certain when observed. This mysterious world challenges our everyday experiences and opens up new possibilities for science and technology. One of the first surprises in quantum physics is wave-particle duality. This means that tiny particles like electrons and photons can act both as particles and as waves. For example, light can travel as a wave, spreading out and interfering with itself, but it can also hit a surface as individual particles called photons. This dual behavior was first demonstrated in experiments like the famous double-slit experiment, which showed that particles can create patterns typical of waves. Understanding wave-particle duality is key to grasping the strange nature of the quantum world. Double-slit experiment is a classic demonstration of quantum weirdness. When light or electrons pass through two narrow slits, they create an interference pattern on a screen behind the slits, just like waves in water. But when scientists try to observe which slit the particle goes through, the interference pattern disappears, and the particles behave like individual objects. This experiment shows that the act of measurement affects the outcome, a concept that lies at the heart of quantum physics. Another fundamental idea in quantum physics is superposition. In the quantum world, particles can exist in multiple states at once. For example, an electron can be in two places at the same time, or a photon can take multiple paths simultaneously. It's only when we measure the particle that it chooses a specific state. This principle is famously illustrated by Schrödinger's cat thought experiment, where a cat in a box can be both alive and dead until someone looks inside. Superposition is a key reason why quantum computers can be so powerful. Schrödinger's cat is a famous thought experiment that helps explain superposition. Imagine a cat in a sealed box with a device that has a 50% chance of killing the cat based on a quantum event. Until the box is opened and the cat is observed, it is considered both alive and dead at the same time. This paradox highlights how quantum mechanics defies our everyday logic and shows the strange consequences of superposition at the quantum level. Quantum entanglement is another mind-bending concept. When two particles become entangled, their properties become linked, no matter how far apart they are. If you measure one particle, you instantly know the state of the other, even if it's on the other side of the universe. This phenomenon puzzled even Einstein, who called it spooky action at a distance. Entanglement is now a key part of quantum technology, including quantum computing and secure communication. Uncertainty principle, introduced by Werner Heisenberg, states that it's impossible to know both the exact position and momentum of a particle at the same time. The more precisely we know one, the less precisely we can know the other. This isn't just a limitation of our measuring tools, it's a fundamental property of nature. The uncertainty principle explains why the quantum world is so unpredictable, and why particles seem to exist in a cloud of probabilities. Quantum physics probability plays a central role. Instead of predicting exact outcomes, quantum mechanics gives us the likelihood of finding a particle in a certain place or state. This is described by a mathematical object called the wave function. The wave function contains all the information about a system, but only when we measure it do we get a definite result. This probabilistic nature is what makes quantum physics so different from classical physics. Wave function is a mathematical description of a quantum system. It tells us the probability of finding a particle in a particular place or state. The wave function can be thought of as a cloud of possibilities spreading out over space. When we make a measurement, the wave function collapses to a single outcome. This idea is central to quantum mechanics and helps explain why particles behave so unpredictably until observed. Quantum tunneling is a phenomenon where particles can pass through barriers that would be impossible in classical physics. Imagine a ball rolling up a hill that doesn't have enough energy to reach the top. In the quantum world, there's a chance the ball can tunnel through the hill and appear on the other side. This effect is crucial in many technologies, such as the operation of transistors in computers and nuclear fusion in stars. Quantum superposition allows quantum computers to process information in ways that classical computers can't. In a quantum computer, bits of information called qubits can be in multiple states at once, thanks to superposition. This means quantum computers can solve certain problems much faster than traditional computers. Quantum computing is still in its early stages, but it holds great promise for the future of technology and science. Quantum cryptography uses the principles of quantum physics to create secure communication methods. Because measuring a quantum system changes its state, any attempt to eavesdrop on a quantum communication can be detected. This makes quantum cryptography incredibly secure and is already being used in some advanced communication networks. It's a real-world application of quantum mechanics that could change how we keep information safe. Quantum teleportation is a process where the state of a particle is transferred from one place to another without moving the particle itself. This is made possible by quantum entanglement. While it doesn't mean teleporting people like in science fiction, quantum teleportation is already being used to transfer information securely over long distances. It's another example of how quantum physics is leading to new technologies. Quantum sensors use the sensitivity of quantum systems to measure things like time, gravity, and magnetic fields with incredible precision. These sensors are already being developed for use in navigation, medical imaging, and even detecting underground resources. The ability to make such precise measurements is one of the many practical benefits of quantum physics. Quantum physics isn't just about particles, it also explains how atoms bond to form molecules, which is the foundation of chemistry. The arrangement of electrons in atoms and the way they interact is governed by quantum rules. This understanding has led to the development of new materials, medicines, and technologies that shape our modern world. Quantum effects are also found in biology. For example, some birds use quantum entanglement to navigate using Earth's magnetic field. Photosynthesis, the process plants use to convert sunlight into energy, also relies on quantum mechanics to transfer energy efficiently. These discoveries show that quantum physics isn't limited to the lab, it's part of life itself. Light is one of the most important subjects in quantum physics. Photons, the particles of light, exhibit both wave and particle properties. Quantum physics explains phenomena like lasers, LEDs, and even the colors we see. Understanding how light interacts with matter has led to countless technological advances, from fiber optics to solar panels. In quantum physics, observation plays a crucial role. The act of measuring or observing a quantum system changes its state. This is known as the observer effect. It's why particles don't have definite properties until we look at them. This concept challenges our understanding of reality and has led to many philosophical debates about the nature of the universe. Time behaves differently in the quantum world. Some theories suggest that at the smallest scales, time may not flow smoothly but instead jumps in tiny increments. Quantum physics also helps explain why time seems to move forward and not backward, a mystery known as the arrow of time. These ideas are still being explored and could change our understanding of the universe. Quantum field theory is a framework that combines quantum mechanics with special relativity. It describes how particles interact through fields like the electromagnetic field. This theory is the foundation of modern particle physics and has led to the discovery of many new particles and forces. Quantum field theory helps us understand the fundamental building blocks of the universe. Standard model is a theory that describes the fundamental particles and forces in the universe, except for gravity. It includes particles like quarks, electrons, and neutrinos, as well as forces like electromagnetism and the strong and weak nuclear forces. The Standard Model has been incredibly successful in explaining experimental results, but scientists are still searching for a theory that includes gravity. One of the biggest mysteries in physics is how to combine quantum mechanics with gravity. Quantum gravity is an area of research that aims to explain how gravity works at the smallest scales. Theories like string theory and loop quantum gravity are being developed, but a complete theory is still out of reach. Solving this puzzle could unlock new secrets about the universe. Quantum physics isn't just about tiny particles, it also plays a role in the evolution of the universe. The early universe was governed by quantum laws, and quantum fluctuations may have seeded the formation of galaxies. Understanding quantum physics helps us answer big questions about the origin and fate of the cosmos. Black holes are regions of space where gravity is so strong that nothing can escape. Quantum physics has helped us understand black holes better, especially through the concept of Hawking radiation. This is a process where black holes can slowly lose mass and energy, eventually evaporating over time. Quantum physics continues to reveal new mysteries about these fascinating objects. Energy in the quantum world comes in discrete packets called quanta. This idea was first introduced by Max Planck and is the reason why atoms emit and absorb light at specific frequencies. Quantum physics explains the structure of atoms and the behavior of electrons, which is essential for understanding chemistry and electronics. Modern electronics, from smartphones to computers, rely on quantum physics. The behavior of electrons in semiconductors, which are used to make transistors and microchips, is governed by quantum rules. Without quantum physics, we wouldn't have the technology that powers our digital world. Lasers are a direct application of quantum physics. They work by stimulating atoms to emit light in a very controlled way. This process, called stimulated emission, was predicted by Einstein and is only possible because of quantum mechanics. Lasers are used in everything from medicine to communication and entertainment. Magnetic resonance imaging, or MRI, is a medical technology that relies on quantum physics. MRI machines use strong magnetic fields and radio waves to manipulate the spins of atomic nuclei in the body. The signals produced are used to create detailed images of organs and tissues, helping doctors diagnose and treat diseases. Solar cells, which convert sunlight into electricity, are based on quantum principles. When photons hit a solar cell, they transfer energy to electrons, allowing them to flow as an electric current. Understanding these quantum processes has led to more efficient solar panels and renewable energy solutions. Light-emitting diodes, or LEDs, are another everyday technology powered by quantum physics. LEDs work by allowing electrons to move between energy levels in a semiconductor, releasing light in the process. This quantum effect makes LEDs energy efficient and long-lasting, revolutionizing lighting around the world. Fiber optic cables use the quantum properties of light to transmit information over long distances with minimal loss. By understanding how photons travel through glass fibers, engineers have created high-speed communication networks that connect the world. Quantum physics is at the heart of this technology. Atomic clocks are the most accurate timekeeping devices ever invented, and they rely on quantum physics. These clocks measure the vibrations of atoms, which are incredibly consistent. Atomic clocks are used in GPS systems, telecommunications, and scientific research, making precise timing possible. Nanotechnology is the science of building and manipulating materials at the atomic and molecular scale. Quantum physics explains how materials behave at these tiny sizes, leading to new inventions like stronger materials, better medicines, and advanced electronics. The possibilities are nearly endless. Superconductors are materials that can conduct electricity with zero resistance when cooled to very low temperatures. This quantum effect allows for powerful magnets, efficient power transmission, and advanced medical devices like MRI machines. Research into superconductors could lead to major breakthroughs in energy and technology. Magnetism at the atomic level is explained by quantum physics. The magnetic properties of materials come from the spins of electrons, a purely quantum phenomenon. Understanding quantum magnetism has led to new types of data storage and advanced electronic devices. Randomness is built into the fabric of quantum physics. Unlike classical physics where events are predictable, quantum events happen with certain probabilities. This true randomness is used in applications like secure encryption and random number generation for computing. Quantum information science studies how information is stored, processed, and transmitted using quantum systems. This field is leading to new ways of computing, communicating, and solving problems that are impossible for classical systems. Quantum information is at the cutting edge of science and technology. Quantum physics has profound implications for philosophy. It challenges our ideas about reality, causality, and the nature of the universe. Questions like does reality exist when we're not looking, and can events happen without a cause, are at the heart of quantum philosophy. These debates continue to inspire scientists and thinkers alike. Many brilliant minds have contributed to quantum physics. Max Planck, Albert Einstein, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, and Richard Feynman are just a few of the pioneers who shaped the field. Their discoveries have changed the way we see the universe and continue to influence science today. Quantum physics has captured the imagination of writers, filmmakers, and artists. Concepts like parallel universes, teleportation, and quantum leaps appear in movies, TV shows, and books. While these ideas are often exaggerated, they reflect the real mysteries and possibilities of the quantum world. Despite its successes, quantum physics still faces many challenges. Some phenomena remain unexplained, and new discoveries often raise more questions than answers. Scientists are working hard to develop new theories, conduct experiments, and push the boundaries of what we know about the quantum world. The future of quantum physics is full of promise. As technology advances, we'll be able to test new theories, build more powerful quantum computers, and develop applications we can't even imagine yet. Quantum physics will continue to shape our understanding of the universe and drive innovation in science and technology. Studying quantum physics helps us unlock the secrets of the universe, develop new technologies, and solve problems in fields from medicine to computing. It challenges us to think differently and pushes the limits of human knowledge. Whether you're a scientist or just curious, quantum physics offers endless opportunities for discovery. We've covered the basics of quantum physics, from wave-particle duality to quantum computing and beyond. The quantum realm is strange, fascinating, and full of surprises. As we continue to explore this mysterious world, we'll discover new ways to understand and shape the universe. Thank you for joining us on this journey into the quantum realm. Stay curious and keep exploring.